Hi everyone, hope all of you are doing well. In this video, I'm going to talk about sampling distribution of the sample mean X bar. So I'm going to show you some application of central limit theorem. Okay, so central limit theorem in summary says no matter the shape of the population distribution, if the sample size is large enough, if the sample size is at least 30, the sampling distribution of the sample mean X bar will be approximately normal with a mean equal to the population mean mu, and its standard deviation would be equal to sigma over square root of n. Look at here, it's the mean of the X bar, mean of the sampling distribution of X bar or distribution of X bar. It's its mean, and its standard deviation would be sigma over square root of n. Sigma is population standard deviation. Okay, so look at here, central limit theorem says if the population is a normal population, the sampling distribution of the sample mean would be a normal distribution. But what happens if the population is not normal? If the population is not normal, so we need to select a sample which is large enough, at least 30 item in the sample is required. Then the sampling distribution of the sample mean X bar would be a normal distribution with a mean equal to the population mean and a standard deviation which is equal to population standard deviation divided by square root of the sample size. Okay, it's the central limit theorem in summary. So now let's solve some application question. Look at here, before solving some application question, if you remember, we used to work with Z to find the probability for X. We used to work with this formula to convert X to Z to find the Z value of X. We used Z equals X minus mu over sigma. But now in this chapter, because we are going to work on X bar, okay? I'm looking for a probability for X bar here in this chapter to determine the probability for a sample mean X bar. Instead of this formula, if I'm going to work with Z value, I need to work with Z equals X bar because now I'm working on X bar, sample mean. So look at here, instead of X, I'm going to work with X bar. What is the mean of the sampling distribution or distribution of X bar? It's equal to the population mean. I'm going to use same mu, population mean. But what is the standard deviation of the sampling distribution? What is the standard deviation of the distribution of X bar? It's sigma over square root of n. So instead of sigma, I'm going to work with sigma over square root of n. Okay, I'm going to divide the population standard deviation by the sample size. So to determine the probability for a sample mean X bar, if you are going to work with Z, standard normal distribution, you need this formula. You need to find the Z value of X bar by this formula. So let's solve this question. Question says a food processing company produces French fries for fast food outlets. The distribution of French fry length is thought to be normal. Look at here. Here, question clearly says we have a normal population. Because the population is normal, even for the small samples, the sampling distribution of X bar would be a normal distribution. Okay. But what happens if population is not normal? If the population is not normal, we need a sample which is large enough. Then the sampling distribution of X bar also would be, the distribution of X bar sample mean also would be normal. But here, because population is normal, okay, then the distribution of X bar is also normal, bell-shaped, and its mean of the sample mean of X bar is exactly equal to the population mean, okay, and it's a standard deviation. A standard deviation of x bar would be population standard deviation divided by the square root of n. Okay, so now let's continue reading the question. Look at here, we have a normal population. The population mean is 4. So its population mean 4. Okay. What is the population standard deviation? How much is population standard deviation? Standard deviation of the population is 1. That's sigma. And I'm looking for the probability of selecting a simple random sample of 100. Look at here, I have a sample size of 100. Question says, what is the probability of selecting a sample, random sample of 100 rows with a sample mean or x bar exceeding 4? Look at here, I'm looking for this probability, P of x bar or sample mean exceeding. It's more than 4.1. Look at it, I'm looking for this probability. I'm looking for a probability for sample mean x bar. So because population is normal, based on the central limit theorem, the distribution of x bar also is normal. So I have a bell shape for x bar. It's x bar. Look at here, we have x bar is approximately a normal distribution. How much is its mean? The mean of x bar is exactly equal to the population mean based on the central limit theorem. Okay, so in the middle I have 4. I'm looking for this probability. To find this probability, look at here, x bar is more than 4.1. 4.1 is on the right side of 4, for example, here. It's 4.1. Okay, this probability that I'm looking for is, look at it, it's 4.1. Because x bar is more than 4.1, all the x bars more than 4.1 are on the right side of 4.1. So I need the area on the right side of 4.1. Okay, so the probability I'm looking for is exactly the area of the red part. Okay, by using Excel, easily we can find the area of the red part, and then we have the probability. Okay, let's go to Excel to find this probability. Look at here, it's the Excel file for this question. We have a sample size of 100. Population mean is 4. Sigma, population standard deviation, is 1. And I'm looking for P of x bar more than 4.1. So to find P of x bar more than 4.1, I need the area of the red part. Okay, so in Excel, just we need to use, look at here, first I'm gonna work with x bar, not z. I can find this probability by working directly on x bar. Okay, but then I'm gonna show you how to find the probability also by z, by finding z value. First, I'm gonna work with x bar because I'm looking for the area on the right side of x bar. So I'm gonna write 1 minus norm distribution, okay? Because if I use norm distribution function to find the probability, it returns the area on the left side of x bar, but I need the area on the right side. So in this case, I need to write 1 minus, okay? Then, so here, x bar is 4.1, okay? Mean is exactly to population mean. But what about the standard deviation of x bar? Look at here, to find the standard deviation of x bar, I need to divide the population standard deviation by sample size, okay? So let's find that first. Look at here. In the norm distribution formula in Excel, I need to enter sigma over square root of n. Sigma over square root of n, or a standard error of the mean, is standard deviation of x bar, of distribution of x bar, okay? Let's find that. In the formula, I need to enter that to find probability. So sigma is 1 divided by a square root of n. Sample size is 100. So 0.1 is sigma x bar, or standard deviation of x bar, okay? So now we can find this probability. So 1 minus norm distribution. Look at it, because I'm working with x bar directly, I'm going to use norm distribution. Okay, so x bar is 4.1. Mean is exactly equal to the population mean, but standard deviation of x bar is sigma x bar, sigma over square root of n, this number. And it's always cumulative. So look at here, it's the probability I was looking for, 0.1587. Okay, it's P of, this number is P of x bar when x bar exceeding more than 4.1. Okay, I can find this probability by z, by using z. Okay, so in this case, first, look at it here, I got this probability by using x bar. I used norm distribution. When you work with x bar directly, we use norm distribution. But if you are going to work with a standard normal distribution, you need to find the z value of x bar. Let's find the z value of x bar. Okay, to find z value of x bar, I'm going to use this formula. X bar minus mu over sigma over square root of n. So let's find z by using this formula. Look at here, I'm gonna sub x bar minus mu divided by sigma over square root of n. We already have sigma over square root of n. Okay, z is 1. Now to find this probability, I can to get the same number, I can work with standard normal distribution. Then I need to work with 1, with z value. Look at here, to find the same probability by using z value, by using a standard normal distribution. Now I'm gonna type norm standard distribution. But again, because I'm looking for the area on the right side, here we look for the area on the right side because x bar is more than 4.1. I'm gonna use 1 minus norm standard distribution. Okay, so here I'm gonna write z, and it's cumulative. Look at it, we get the same number here, but here I use the standard normal distribution. Okay, so this probability, the area of the red part would be 0.15, based on the Excel file, 0.1587. Okay, now let's go to another question. Look at here. Here question says, what is the probability that the mean of sample, or x bar, mean of the sample is x bar, is less than 3.85 inches. Look at here, now I'm looking for P of x bar, probability that x bar sample mean is less than 3.85. Look at here, now I'm looking for this probability. So to find this probability, we have a situation like this one. Look at here, based on the sample, based on the central limit theorem, x bar is bell-shaped, it's normal. Okay, in the middle again, we have mu x bar is exactly equal to the population mean, 4. Okay, but look at here, here I'm looking for P of x bar less than 3.85. 3.85 is less than 4. It's on the left side of 4. So here I have 3.85. Okay, and x bar is less than 3.85. All the x bars less than 3.85 are on the left side of 3.85. So now here x bar is on the left side of 3.85. So the probability I'm looking for is the area of the shaded part, this part. To find the probability, I need the area of this part. I can find this area easily by Excel. So the probability we look for is the area of the red part, the area of the shaded part. Now we need to go to Excel. Look at here I have P of X bar less than 3.85. And here, because I'm looking for the area on the left side, so just I'm gonna use norm distribution if I work with X bar directly. So how much is X bar? 3.85. Mean is exactly equal to the population mean. Population mean. The standard deviation is 0.1. Standard deviation of X bar. And it's always cumulative. Look at here, we get this number. Here again, instead of working with X bar directly, I can work with Z. I can find the same probability by using a standard normal distribution. So in this case, I need the Z value of 3.85. To find the Z value of 3.85, I'm going to use again this formula, okay? So I need to subtract, I need to make a subtraction between X bar 3.85 and mean 4. Then divided by standard error of the mean, or sample mean standard deviation. Okay, so it's Z value of 3.85. Now to get the same number, I can use easily norm S distribution. I'm gonna work with standard normal distribution. Z is minus 1.5 and it's always cumulative. Look at here, we get the same number here. It's the probability of X bar less than 3.85. This here I used X bar directly. I used normal distribution, but here I used standard normal distribution. I use Z value.